and welcome everyone to the last in the second of a very successful series of webinars on the built environment and AI. The aim of the Franco-British Data Society is to bring the world of work and the world of education together. And so it's fitting and very welcome that we should have this talk given by Frédéric Bosché, who is reader in construction informatics and leader of Cyberbuild Lab in Edinburgh University. Without any more ado, Frédéric, I'd ask you to start your talk.
Thank you, Michael. Just before Frédéric start, just a brief introduction on us as well, airc.digital co-organizing the webinar with the Franco-British Data Society. And very important for us, the subject today, because education is a big topic. It is something we have been working on for several years now, developing programs with Build Studios, Nemetschek Group, in trying to bring the knowledge of the field into the classroom. And when we started to be involved in Edinburgh, Frédéric is one of the great person we met then, because we were able to have really a frank discussion about the sort of the state of the education sector within the construction industry overall. And then today we'll talk about the civil engineering industry or civil engineering education. And we had several exchange, and we'll probably develop a few of these during the questions after, that it's very interesting and important to understand that the change in the eco industry worldwide start with the implementation of these changes in the education sector. So anything we can talk about in terms of trends, including AI, and especially AI recently, has to be implemented into the education sector for the construction industry. If it is not, we can't guarantee that it will be applied to the day-to-day practice. So yes, it's very exciting. Thank you very much, Frédéric, to be there with us today, and really look forward to your presentation and maybe discussing it after. Anyone, obviously, in the audience, if you have any question, please feel free to pop them into the chat and we can discuss them after. So thank you, and the floor is yours, Frédéric.
Okay, thank you very much. Can you hear me all right? Yes. So thank you very much for having me today. So I'll give you some thoughts on AI and how we embed this in civil engineering education. I'll particularly talk using the context of the University of Edinburgh program, but I'm pretty sure this is quite representative of what's happening across the UK. But first of all, AI in civil engineering is useful because we need to solve complex problems, and in fact, increasingly complex problems, and this spans, the entire life cycle of projects. And there are applications from, at urban planning level, at design, asset design, space exploration, optimization. Then during construction, there are great applications of AI for improving performance. And then during the operation, how to optimize maintenance and the operation of assets. So civil engineers are involved throughout the life cycle, and there are applications of AI across the life cycle. I should take a note here, because I will revisit this a little later, that I mean AI here in a very broad sense, and its original sense, not necessarily the more specific sense we tend to apply today. My slide didn't go. Here I go. I thought it was very timely. I noticed that very recently the ASC had an article published called "What Do Civil Engineers Need to Know About Artificial Intelligence?" And that was just about a month ago. I don't necessarily agree with everything that is in there, actually, but it just shows that yes, you are interested. Lots of people are interested in this, and how do we need to evolve education system to take this into account? A little bit of background about civil engineering education in the UK. We are accredited by the Joint Board of Moderators, JBM. Pretty much every civil engineering degree will be accredited by them. And they have quite some requirements, quite an extensive set of requirements of expectations about what are in civil engineering degrees. There are core subjects that need to be studied around structures, materials, geotechnics. They expect at least a minimum of 2 of the following subjects in the second column, and they want all these to account for sustainability, construction aspects, and health and safety. So all this needs to be somehow, included in a B-Eng or most likely M-Eng program. And, we start from high school students, many of them may not quite know what civil engineering is. It's not a subject you study in high school, so you tend to have to build on existing subjects from high school. At the University of Edinburgh, by the way, this is pretty much how we meet those requirements. We are very strong on the bold orange topics here. We are in the sense that we cover them extensively, more extensively in the program. And then the light orange are things we offer, that are covered in the program, but I would argue not to great extent. And then very light orange, fire engineering, architecture engineering, IT, we cover them well, but these are elective. So they're for people who really want to get into architecture and structural engineering or civil and fire engineering. So they are electives. So we try to cover as much as possible, but the implications of that, as you'll see, is that programs are pretty busy. By the way, if you look at the JBM documentation of what they expect, I looked at where do they talk about BIM or informatics or AI, and really they only talk about it in 2 very small places. One regarding the focus on design. They say undertake proficiently digital modeling, output validation, and parametric design, which is actually quite good. It's 1 line. And this is about knowledge and understanding. It's not necessarily practical skills. In practical skills, they say demonstrate clear communication skills through their sketching, drawing, and modeling, whatever that means. But this is the only practical skills I see there. And then surveying, they make reference to point clouds, information extraction, basic geometry and 3D modeling for me. But again, this is all about mostly knowledge and understanding. So students are mostly expected to have knowledge and understanding, but not necessarily a lot of practical experience. At least these are the minimum standards set by the JBM. Now, as I said, this is the consequence of all these requirements on a civil engineering degree at the University of Edinburgh. I am not going to go in detail covering all this. You can have a brief look at this. But the question is, where do we talk about programming, AI, digital construction, digital engineering there? And actually at the moment, and I think it's a bit reductive, but I'll say the main focus at the moment, they here. The students have an introduction to programming inside a design course in year 2, where they learn essentially Python. And then some of that is used in many courses. There are projects here and there where they have to use a bit of Python, etc. And then in 4th year, there's the digital construction course that I lead, where we do things around parametric modeling. I teach building information modeling, things like that. And at the moment, this is just an elective to civil engineering students. Now, we are in the process of moving some of that in the year 2 course and make the year 2 course a bit bigger so that we can go into more advanced stuff in year 4. But, from where you see AI in the program, this is the only place where you see it. The only exception to that, because I surveyed my colleagues about this, is the capstone project or thesis projects in final year. So this is where some colleagues of mine, not many, but some, certainly offer topics that are about applying some sort of AI, more advanced AI technology for solving certain problems. But it's not heavily included in the current curriculum. And there are various issues around reasons behind this, I should say. An important one, which we can always talk about later if you want, is actually the upskilling of the staff who teach on those programs. Because this has progressed very quickly in the last 5-10 years, but a lot of people here have not necessarily had that education, that training, and therefore that's my experience is that this is part of the challenge. What do we need to cover if we want to do something good around AI in construction? There's an aspect of understanding. You can see on the right-hand side, we need to develop skills. We need to actually develop the right attitude of students. And I thank a colleague from Australia to actually bring this to my attention in the recent weeks, which I think is also very important, the general attitude of students. And also an important thing which I'll touch upon is having the material, so stuff we can use to actually engage students around these topics. The first one in terms of skills, we in our program, and most people essentially, we engage students around programming. As I said, I think they learn Python, they do some programming. I reuse Python later on in my course. I think they get some. I think we could do more, definitely. Students should be able to use scripting much more confidently across the different subjects they study. How AI works, this is the basics that should students have in terms of knowledge, at least understanding how these AI models, deep learning models in particular, work. I think students have no introduction to that at the moment, and this is something we would need to cover. I think an important aspect of going towards artificial intelligence in civil engineering is the more lower but foundational thing, which is object-oriented modeling, which is the basis of BIM, let's say. Students now have a solid introduction to that to try to understand what's the difference between modeling with smart objects as opposed to modeling information using just words or just lines for when it comes to drawings, etc. In terms of material, I think this is something that the industry needs to support us better with, is that we need use cases, we need data, we need stuff we can use in order to teach with the students. And this is quite hard because we find the industry is very protective. This is a bit of a USP for various companies, and sometimes they don't want to necessarily share some of the things they have. But if we want to train students on these topics, we will have to generate. So for example, even in building information modeling, there's not a lot of models out there that are freely available that can be used for doing a number of things. I mean, especially like in IFC models, for example, for those who are familiar with open standards. The only good initiatives that come in this area come from the Netherlands, not from the UK. So something we need to do ourselves, but I think the whole industry need to push as well. And finally, there is attitude. So attitude is, there's various things. There's experience, which students don't necessarily have a lot of experience, as I said, mostly because we lack opportunities to offer to them. We like data and use cases. We have a little bit of it, as I said, but not enough. Socialization is actually an important aspect of attitude, is like being able to engage with your colleagues and partners and different disciplines. And I think actually we do this really well at the University of Edinburgh, also through the form of very good cohort lead, a lot of projects that are collaborative. I think we do well. We can always do better, we do well. And by the way, a very good motor of this is the Civil Engineering Student Association that are extremely active here, and we work very closely with colleagues and staff. So we do really good well. And then we need to build student resilience, because I think getting into these kind of things and new innovations, etc., you need to be resilient. You need to accept that things will not work at the beginning, but then they will work, and there will be failure, and you need to be resilient and you need to be able to engage with those challenges. And students, I would say, build reasonable resilience through their programs. I see how the mature and how our final year students, especially MN students, are quite good, but I think we can do better there. In the UK, and I can touch on that later, compared to France, we don't let students fail very much. In France, education likes to fail students. They try to break students and build their resilience through failure. But that also has some negative aspects to it. And I have to say, we've used to have a lot of international students, especially European students on the program because pre-Brexit. And I had to say a lot of continental students tended to be a lot more resilient and more performing, especially in final years, because they had some of that experience, I think. Okay, skills. In terms of programming, this is foundational. We need to build programming skills. There's core programming, and that can be done. I think we need to cover things that are either Python or C# because these are core to the industry. We put all our eggs in Python right now, and I actually think that's fine. Okay, I think the skills you learn there are transferable to other languages. The very important shift we made in the past 3 years is go away from MATLAB and get into Python because that has much more broader benefits and applications. When it comes to computational engineering, then we need to engage students around Grasshopper or a Dynamo, and then around various types of libraries that exist in Python in particular to enable scripting and design and engineering. Now, we do some of that here, but I think we will continue to do more of that. This is where you get into really the computational engineering and design. And then the ultimate step is to engage students around generative design and design optimization. So not just smartly generating solutions, but actually generating many solutions and try to find the optimal ones. And for this, we need to teach around optimization algorithms a little bit at least. And then we need to teach students around artificial intelligence to help them to harness artificial intelligence to help them explore the solution space and find optimal solutions. This latter part we don't cover very much. I'm only engaging students starting this year around generative design, and the only thing they will know about essentially there are tools you can use essentially based around genetic algorithms, and they can do stuff, but they won't have. I don't think they should be experts on this. This is not the purpose, but I think they should have awareness of optimization algorithm, and they need to have an awareness of what are the weaknesses of artificial intelligence and what are its strengths so that they can better understand when these tools fail, because otherwise they might end up believing things that are completely nonsense. And to go on that, I will touch a little bit in the last few minutes on AI and the evolution of AI and where we're at. We've been going AI from using very heuristics and rule-based models to do things towards machine learning, and now a lot of AI solutions are focused on deep learning. So heuristics, essentially engineers define the rules and the codes. Machine learning, they define what are the important features, but then the algorithms or these AI solutions essentially figure out how to best combine those features to find solutions. And deep learning, essentially, you just feed the data and the algorithm learns everything. Now, the more you go towards the right, the more data you need to provide. And the more risks there are actually that you get into some sort of biases that are hard to actually discover. As I said, on the left-hand side, we go from a purely domain knowledge-informed design of models towards mixed. And on the right-hand side, we have really purely data-informed. So almost expert knowledge is almost disappears, and we purely try to learn things from data. Now, we've been selling the right-hand side for quite a while, saying this is going to just change the industry, and not just this industry, many industries. It's just going to revolutionize. There are the doomsday, many jobs will disappear, etc. But I would like to show you some examples. Actually, I'll skip that when I come back. This is the kind of generative AI state of the art you can get to generate a video of a gymnastics professional, right? And this is this is a generative model that was trained with like incredible amount of data, okay, by top tech company in the world. And, they haven't sorted everything yet, right? And this is what you get when you have a lot of data already at hand. So there are still a lot of challenges, and people shouldn't believe that, these AI tools, they'll just revolutionize everything. They work very well in certain niches, which are relevant for civil engineers, like AI for helping coding. These work really, really well because they work with very well structured domains. But when it's much less structured, like here, it's much harder. And for these reasons, we are seeing an evolution where we are kind of like people are trying to go away now from pure data-based models to, again, some sort of mixed models where we combine domain knowledge with data informed solutions. Now, terminology we use there includes things like neurosymbolic AI, or there are also aspects of having human in the loop AI where somebody works with the artificial intelligence and try to get to the solutions. These are really good. And by the way, they will only work well when the person who uses them knows what they're doing. Because if you don't know what you're doing, you're going to make pretty bad mistakes. So they will, we need to engage students around these things, but it's very challenging. We are just at the beginning. I think we actually need to engage the whole industry around these things.
Frédéric, excuse me, you're now in the last 5 minutes.
Well, which is very convenient because I only have one more slide. And so this is, one thought I would say, like, AI, it's still evolving. There's still a lot to be done, and we shouldn't throw all our eggs into it. Now, there are some great examples. I don't know if you've heard recently, a university in China unveiled Civil GPT, which is a good idea, actually, which is about feeding ChatGPT or ChatGPT type LLM with a lot of content from their courses, from professional material, textbooks, etc. And that can be used by their students to actually support their learning, okay? And it can be used to... Now, there are very big risks around this, definitely, but there are some, it shows that there is a lot of effort that try to develop also AI solution towards the education level or aspect of civil engineering. Okay, I'll leave it there. I try to cover a few things. I hope it was interesting enough. I'd love to hear your thoughts on this as well, and any questions you may have.
So would people like to raise their hands for a question, or and you'll spot them and let them in, will you? Maybe I can just kick off with a question.
Yeah.
Upskilling of existing staff.
Yeah.
What are the sort of key elements to get this going?
Well, I mean, I think there is always a number of people who actually are worried about being overtaken by new things and then don't engage, and then and then becomes a vicious circle. So the later you leave it, the more out of context you are, and the harder it is to catch up. But certainly we have to do things. So at the University of Edinburgh, for example, the university, in collaboration with the School of Informatics, has organized courses for its own staff to come and try to get to train them in using AI or in better understanding AI, and develop some practical skills. But I think this is something we need to push more. And actually, it's not just AI, by the way. It's like historically, it's just been programming. I mean, it's just some of the basics. It's not even just AI. It's just getting people into programming, realizing what can be done, even with just computational engineering. This would already be good if we actually improved some of the skills we have. And that could be done also by professional bodies. They can engage people in industry and in academia and provide some training around these things.
Thank you.
But I have to say, there's a big push. We have an industry advisory board at the university in civil engineering, and every year the first question they ask is essentially something for me. It's essentially, what do you do around programming? What do you do around BIM? I think the last years were BIM, and this year was AI, right? So the first thing is these topics, like what do you do about training students on that? So there's a push, but I don't think it can be covered by just one course delivered by me, right? It's something that has to be permeable and go across many courses.
Thank you.
Just maybe one question, Michael and Frédéric. I think when we prepared that webinar and we had the initial discussion, what we realized, and it was quite sobering within that AI bubble, is actually the interesting topic of discussion is almost more the absence of AI in the education industry, more than AI totally changing it. So it is sobering in the way that we have been told, as you said, that AI was going to revolutionize everything in our society very quickly in 2024. What was very interesting and encouraging is to see that the foundation of our society, which is education, is yet to be fully transformed, and maybe it will happen gradually. And I was interested to know what your feeling is about that, on how AI is going to infiltrate the education sector and maybe change it.
I mean, the education sector itself, I think things like civil GPT or something like that will be becoming very available across the board. You know, you could have an ICE GPT, you know, the Institute of Civil Engineers could actually create a GPT resource for all its members and students. And then we'll have to build our education system on that. We can use that. I mean, it can be used to help students so that you can have like agents that actually, virtual agents that actually monitor students and how they well, and then, you know, ask them questions and try to consolidate their knowledge. As I said, there is, however, a risk, right? We need to make sure that the students have the foundational knowledge and don't necessarily go out believing they will always have a civil GPT tool next to them to give them answers. And regardless, they need to make sure the answers are right, you know, and that they make sense, and that they do not include any sort of bias or misunderstanding of the questions. Because, I mean, just like we've seen with the rise of, you know, Google and other tools that have helped the finding information, students have taken very often information in face value without really understanding what that actually meant and whether it made a lot of sense. So it will, like we always say, you know, industry will not be displaced by AI, they will be displaced by somebody who uses AI, right? So these are the kind of graduates we want to have, is graduates who are smart and are able then to use AI effectively in their work.
Thank you. I think we've got time for one last question. Anne, is there someone waiting to be admitted?
Yes, there is one from Ludovic. Could you comment on how ready high school students are to enter university on this matter? Do they have all the same appetite and knowledge? And should we, sorry.
Yeah, I see the
should
question.
We do more at a younger age to prepare them? Yeah.
Yeah. Well, I mean, I think programming is something that they may want do a bit more at high school, but I think they are engaging some. I think it's more like, obviously, high school, you have to cater for a range of careers, right? So they do offer some programming to students who want to get into science and engineering potentially. This is happening, but honestly, with the issues we have with education in the West at the moment, I would rather have high school still may put a lot of focus on mathematics and physics and the very basics, because this is, you know, if you don't have mathematics, you will not be good at programming. If you don't have, you know, there are a lot of, we shouldn't try to engage in new things and let the even more foundational topics get worse. I think we need to continue to engage students on math and physics in particular. One thing that has been interesting in terms of recruitment is that civil engineering has been struggling to recruit across the UK in recent years. And I think one of the consequences of that, one of the reasons for that, is the fact that there has been a big national push for computer science. And that has been successful. They are getting a lot more students in those topics because, you know, the UK said we need to be a superpower in computer science. But the problem is we've done that at the expense of engineering. And so somehow we will have to rebalance or enhance, you know, primary and high school education to get more people in those subjects, maybe. But this is something that I think the engineering generally, but actually the ICE in particular, has overlooked and needs to respond to. We need to get more people in schools in order to engage students around the domain of civil engineering, which they typically don't know of because this is not something you study in school. So most people we hire, I used to teach on a construction program. Now civil engineering is a bit different, but I used to teach a construction program. It was incredible when I asked students, do you have, or students who were coming in the program and say, why do you study construction and how did you learn about construction, etc.? And very often it was because somebody in their family was in the sector, right? So if we want to be able to get people who don't have somebody in the sector work in civil engineering, and actually the smarter people as well, then we need to be much more engaging with high schools. And, you know, we try to do that, but it's challenging. And we also need to get high school teachers to be a bit less worried and fearful about engaging with topics they don't have familiarity with. One last point about this. I know that there is a hires in sustainable infrastructure that is being trialed in Midlothian, so just south of Edinburgh. And that could be also a way to help, because then students will have exposure to civil engineering, construction, what it is, and they are much more likely to then choose this sort of education if they have these sort of hires available to them.
Thank you very much. I think at this point
sorry, Mike, we have one more question, and I would like, if we have time, it's just on the chat already. It's from someone who studied engineering both in France and Australia.
Yes.
And saw difference between the way of learning engineering. In France, much more theory, based on theory, and maybe drawing plans by hands, whereas in Australia it was more software oriented. So do you think that the old ways of doing will entirely disappear, or they will be completely like replaced by softwares, or will be in between?
No, I mean, I think the French system has evolved as well a bit. I think there is a lot more of this happening. But yes, in France, there's much more focus on the foundations, particularly because, so it's not true across the board, but we have the Grandes Écoles in France. So the first 2 years of your engineering degree, actually, even if you do it in integrated engineering schools, you will do very little engineering related stuff. You'll just do math and physics, and to a greater extent that we even cover in the UK, like the number of hours of mathematics I did were crazy. Now, I think it went over the top to some extent because I never actually needed a lot of what I studied, but it certainly built my logic, which was very good to then get into programming. And it also built my resilience. I think we were pushed very hard on those topics, not just because we needed to learn those topics, which were still important foundations of engineering, but also because we wanted to build our resilience and around that. And this is something that I found is a very continental thing. But what we call in France Anglo-Saxons, typically Britain, but also America, tend to not push too much this learn by failure kind of experience. In France, there's a lot more of that. And I see benefits of both, really. So in a way, maybe it's good to have been educated in both environments. Okay. And so have I, by the way. So have I. I have been educated in North America as well. So.
Frédéric, you show little signs of having failed at anything. So I take this opportunity to thank you very much indeed for an outstanding talk. And I thank Pierre and his company airc.digital for all the support they give to the Society, which I encourage everyone on this call to join. Go to our website, easy to find, and join up, please. So thank you, everyone, and au revoir.
Thank you very much.
Thank you very much. Au revoir.